Hello there. Today's lesson is 9.3, the parabola. This is the last of the conic sections that we're going to discuss. And in this video, we're going to talk about graphing parabolas with vertices at the origin and off of the origin. We're going to write equations of parabolas. We're going to solve applied problems. And then we're going to identify conics without actually completing the square. So first and foremost, the definition of a parabola. A parabola is the set of all points in a plane that are equidistant from a fixed line called the directrix and a fixed point called the focus. So here is our picture. I'm going to go back to that definition, that interactive one that I like to show you. Here it is in a different orientation. So yes, we're going to have parabolas that go up and down, or they can go left and right. But here's my directrix, here is my focus, and as you see this point P, you can tell by the distance, okay, that P is halfway between the focus and the directrix. That's going to actually be the vertex of our parabola. But as I drag this down, you see that every single time, wherever I stop, the distance from P to the directrix and P to the focus is always the same. That's how we get the parabola. The other parts of the parabola, as I just said, we have the vertex, okay, that is halfway between the focus and the directrix. So if you know those two, you can always find the vertex. This, of course, is our parabola. And then last but not least, we don't talk about it as much in pre-cal as you do in Algebra 2. But remember that there's an axis of symmetry that folds your parabola in half and has a mirror image on each side. So first off, standard form of the equation of parabola, centered, whose vertex is at the origin. Okay, if the vertex is at the origin, we're either going to have y squared equals 4px or x squared equals 4py. Now, you've got to remember which one goes which, but I hope that you will remember that what you learned before today, I don't think you did these in Algebra 2, okay? But before today, you have known that y equals x squared is a parabola going up. Y'all know that. So if you remember that, then you know when the x is squared that the parabola is what we call vertical, going up or down, depending on the negative. If the y is squared, it's going to open right or left, again, depending on the negative. Okay, so we have our directrix. This dotted line is our directrix in both cases. Then we have our focus. Well, we have our vertex and we have our focus. And one of the things, as you can see from this one here, P0. So P, this is the only new vocab that you really have in this, is that P represents the distance from the focus to the vertex and the vertex to the directrix, because they're halfway between. So it's P whichever way you go. All right. If in my vertical parabola, I have my focus, I have my directrix, and then I have my value of P, that is the distance from the focus to the vertex. I didn't label that vertex. Okay. Now, one thing to help you get things straight, to keep things straight, okay, whichever variable is not squared, that is the equation of your directrix. It has to be x equals. And I'm just trying to help you keep that part straight. Otherwise, I don't remember the formula so much. I know that P represents the distance, but I'm going to help you. So x is the one that's not squared. It's the directrix, x equals. If y is the one not squared, then you're going to have a horizontal directrix, and it's going to be y equals some number. So look at what we have. Finding the focus and directrix of a parabola. Okay. Find the focus and directrix of the parabola given by y squared equals 8x, then graph it. Okay, so I hope you've been watching. I'm going to graph it first, and then I'm going to go find the focus and directrix from my graph, because I think that's easiest. So first and foremost, remember that y equals x squared is an up-down parabola. So this case, I have y squared, so I know it's going to open to the right. If there was a negative sign in front of my 8, it would open to the left. Okay? My vertex is at 0, 0, so I can go plot that. Let's go up here. Nope, this one. All right, so I got 0, 0. And then the number in front, 8, if you remember from our standard form, represents 4p. So 4p equals 8, and p equals 2. So if my parabola opens to the right, this is my vertex, okay? Then I'm going to go 2 to the right, 1, 2. And that is going to be my focus. And 2 to the left is going to be, I don't do very well drawing, without a straight edge. But anyway, this is my directrix. That's my directrix. And remember I said the directrix, the equation of it, well, we'll come to that in a second. We have to do it. Doesn't look like a D. Let's go here. Put it right there. D. Okay. So to graph it, okay, I will also tell you that this 8 is the distance between the focus. So I'm going to go 4 above the focus. 1, 2, 3, 4. Has a special name I'm going to talk about in a second. 1, 2, 3, 4, 4 below it. And then I'm going to connect it. Well, in a really poor way, but you got the idea. And that's all we have to do to graph the parabola. Okay? I have to give the focus. Well, look, y'all, I didn't have to remember any equations. I just know that it's p distance away from the vertex, and it's inside the curve. So what are the coordinates of that point? Well, my focus is, of course, 2, 0. And then my directrix is the other way, and that's what I told you. Directrix is the one that's not squared. So my directrix is going to be x equals -2. And that's what we got. Bad drawing. I'm sure y'all can do better. Okay, so this distance here that I was just telling you that I used to graph it, these two endpoints, if you are connecting them to a segment, that segment has a special name, and it is called the latus rectum. Comes from Latin, which means straight side. The straight side of a parabola is a line segment that passes through the focus parallel to the directrix and has its endpoints on the parabola. And the length of that latus rectum is always the absolute value of 4p. They say absolute value because it's a distance. The length can't be negative, but the negative just tells you which way it opens. So what I just did, this right here is the length of your latus rectum, and it's got to go through the focus, and its endpoints are on the parabola. So it kind of makes it an easy way to graph. All right, so look at this next one. Find the standard form of the equation of a parabola with a focus at 8, 0 and a directrix at x equals -8. So you know I'm going to graph it. I'm going to go plot that information. All right, that's my line, x equals -8. This, of course, is, well, no, this is going to be the point 8, 0, and that is my focus. And halfway between, if I go 8 in that direction and 8 in that direction, then halfway between has to be my vertex. So my vertex is at 0, 0. And remember, the directrix is not squared. So that means I know that my general equation is going to be y squared equals 4px. So now what do I need to finish that? I got to find out what p is. Well, p is the distance from the vertex to the focus. So p, I know that 4p is going to equal 4 times p. P equals 8. If p equals 8, then 4 times p is going to equal 32. And that is what I'm going to put into my equation. Y squared equals 32x. And that's all you got. All right. Now, all of our parabolas will not be at the center, at the origin. Sometimes we'll have a new vertex, but just like we've been doing all year and in the first 2 sections of this chapter, okay, our vertex could be HK. H moves it left and right. K moves it up and down. H is always with X. Y is always with K. So that's the key thing that you have to remember, and everything else is going to be the same. So look at this problem. Find the vertex, focus, and directrix of the parabola given by x minus 2 quantity squared equals 4 times the quantity of y plus 1. Then graph the parabola. And as I've said to you, I'm going to graph it first because it makes things easier. However, I'm going to stop. If it's x squared, then I should know whether it goes up or down or left and right. So say that to yourself. Hopefully you're right, because the answer is it goes up. It goes up because x is squared. It doesn't go down because there's no negative in front of that 4. Okay? So then my vertex is at HK. H is always with x and K is always with y. So that means that my vertex is going to be 2, negative 1. So I'm going to go plot 2, negative 1, 2, negative 1. There's my vertex. I know it's going up, so I'm going to go ahead and put that V down there. All right, so the next thing I need to know is I got to find P to be able to graph it. And this right here represents 4P. So 4P equals 4 and P equals 1. So if I'm going up, then this right here is my focus. And 1 away down is going to be my directrix. Clearly I do better doing left and right than up and down. So that is find the vertex, focus. So I got the vertex. I can find the focus. The focus again is 2, 0. My directrix is, okay, remember it's the non-squared variable. And in this case, that is going to be y equals negative 2. So that is all that. And then to finish graphing, I'm going to go to my focus, and I'm going to use this number here and go half on each side of my focus. So I'm going to go half of 4 is 2. So 2 to the left and 2 to the right. And that is all that you have to do. If you have to, that's all you need to know to be able to pick it out from your graph. All right, an application. An engineer is designing a flashlight using a parabolic reflecting mirror and a light source. The casting has a diameter of 6 inches and a depth of 4 inches. What is the equation of the parabola used to shape the mirror? And at what point should the light source be placed relative to the mirror's vertex? Okay, so as I mentioned with ellipses, when I have a problem like this, I'm going to go plot it, put it on a set of, on the coordinate plane, on a set of axes, centered at the origin. Makes life easy, okay? If it is 6 inches across, then I know that this is going to be, on the left is going to be negative 3, and on the right is going to be positive 3, and I'm going to go up 4. So that makes the point on the right at the top of my reflecting mirror 3, 4, and the one on the left is going to be negative 3, 4. Now, obviously, there's some point inside my curve that represents the focus, okay? And I've got to be able to find that. I got to find the equation. So to find the equation, I need to find the P value because my focus is at 0P, okay? The parabola goes up, and if it goes up, then I'm going to have x squared equals 4py, and I'm going to go plug in, okay? I'm going to pick a point, and the easiest point to pick is this guy right here. I'm just picking a point on there, okay? I don't want to pick 0 because if I pick 0, then, it's not helping me find P. So I'm picking one of these points, and I'm choosing 3, 4 because they're both positive. So 3 squared is equal to 4p times y is 4. So that means that 9 equals 16p and p equals 9/16. So I'm just going to go now I go plug that in, okay? If I plug that in, then I'm going to have 4 times 9/16, and that becomes 9/4. So my equation is going to be x squared equals 9/4 y, because I just plugged in. That's 4. This is 4p. Okay. At what point should the light source be placed relative to the mirror's vertex? Well, what is my p value? And this right here is my p. Okay. And so that's where I want to put it. And so I'm going to put it 9/16 above the vertex. All right. Last thing that we have to talk about is being able to identify a conic section without completing the square. You probably would like this because you don't have to complete the square. So what is different about this equation? You've never seen one like this. And so what is new is actually having this xy term. So if you don't have an xy term, then it's easy to tell by looking at A and C what it is. And I hope you figured that out. But if not, if you have an xy term, then you need to pay attention, and we get to use this thing called the discriminant, b squared minus 4ac. And if it is less than 0, it's either a circle or ellipse. So these two are together. And if it's equal to 0, it's a parabola. And if it's greater than 0, it is a hyperbola. So if you remember that hyperbole, greater than 0. All right, let's go down and do some problems and see what you have to be able to do. Identify the graph of each of the following non-degenerate conic sections. So I have 3x squared plus 4x minus 2y plus 3y squared plus 6y plus 64 equals 0. So I have an xy term, okay? And in my definition that we just talked about back there, a is the coefficient of x squared, b is the xy term, and c is the coefficient of y squared. And they do have to all be on the same side of the equation, which they are. So my formula was b squared minus 4ac. And if I plug in, b is 6 squared minus 4 times a times c. And that is equal to 0. And if it's equal to 0, then we know we're going to have a parabola. All right, look at b. And hopefully you notice there's no 0 in B. So that means I have to get everything to one side. And it doesn't really matter, but I'm just going to choose the one where the side that I have x squared being positive. It doesn't matter, y'all. You will get the right answer. You just got to make sure they're on the same side. So I'm going to move my 3y squared over, and that's going to give me 6x squared plus 2xy minus 3y squared. And to be perfectly honest with you, the rest of it doesn't matter, because this is my A, this is my B, and that's my C. So B squared minus 4AC. B is 2, so 2 squared minus 4. A is 6, and C is negative 3. And when you multiply that out, you get 76, which is greater than 0, and greater than is that hyperbola. All right. And in the last one, getting everything over to one side again, I got to move the 4xy to the other side. So you can move it all. 0 is equal to 2x squared minus 4xy plus 8y squared plus all the rest of it. Because really all I care about is A, B, and C. So when I plug it in, b squared minus 4ac, b is negative 4, but we know when we're squaring it, we don't need that negative. So 4 squared minus 4 times a is 2, and c is 8. And that is negative 48, which is less than 0. So then I go back and look at my a and my c value. A is 2 and c is 8. So since A does not equal C, then we have an ellipse. If they were equal, we would have a circle. And that is all we have to our conic sections. Thank you so much for watching, and y'all have a great day.